All right, welcome back, everybody. It's another episode of ChatLoopBackOff. I'm going to go ahead and cut into the background, introduce yourself and what we're talking about today. Looking forward to seeing all your comments.
Hello, guys. Nice to meet you. I'm very proud to be here in this new episode and talking about this amazing technology about K8gb. Probably, if you're the first time saying to me, you will enjoy a lot. So, my idea or strategy right now is trying to explain how ambassador or CF ambassador can learn this kind of technology in the first time. So, it is my strategy. I hope that you can enjoy it. And let's get started. Let me introduce you a little bit about me, of course. Um, I am from Costa Rica. My name is Gerardo Lopez Falcon. I'm very proud to be here. I am CNCF ambassador, Cube astronaut. I work on Veritas Automata like a principal engineer. So nice to meet you, all the people. This is the first time that we have connection. So my strategy always when I am trying to study something is first go to the theory. In my strategy, probably you could be different, but let me explain you in 5 minutes a little bit what is the idea about this troubleshoot or this demo, or probably not demo, how we can study together this technology. Okay, the introduction. In today's world, applications and services are not longer confined to a single data centers. It's probably everyone knows this. So we live right now in multi-cloud or hybrid cloud world, where applications are often deployed across multiple geographic locations and, of course, cloud environment to ensure resiliency. Important topics. Pay attention. Resiliency, low latency access, and of course, disaster recovery capabilities. So constantly, as your infrastructure grows, managing traffic routing across multiple clusters and regions becomes a complex challenge. Always, of course, because you have multiple providers, multiple clusters in different regions. You need to probably create or buy different support application or infrastructure. It is a challenge, of course, because you are getting more customer, you are trying to expand your feature, your product across the world. Of course, you need to invest and grow your infrastructure. This is where global load balancing comes into play, ensuring the traffic is intelligently distributed based on factors such as proximity, availability, and failure scenarios. So, what is GSLB? Because at the end, the idea of this session is talking about K8gb, and K8gb really is a GSLB. It means a global service load balancer. It isn't a new concept. Regularly, if you search on internet, you will see different concepts. You will see different products or different capabilities that other customers or companies are offering. But let me explain you a little bit. It is the first time saying to me what is. It is a concept in contrast to single cluster load balancing. Of course, regularly it is a strategy that the most of the products use, which mainly serve as an entrance to a cluster to distribute traffic within the cluster, whereas GSLB typically acts as an entry point. Imagine this, an entry point for traffic across multiple clusters. It means we have multiple clusters in same or different regions, and we have one load balancer switching the traffic across these clusters. The idea, handling load balancing and fault management. Okay, what is K8gb? K8gb is a Kubernetes global load balancer. It's an open source project designed to manage global load balancing for multi-cluster Kubernetes environment, and it allows us to distribute traffic across multiple clusters based on several criteria, such as general geographic location, health of the cluster, of course, because constantly the operator of this product is checking if the cluster or the ingress controller are healthy or not, of course, and traffic load. In simple terms, K8gb enables intelligent traffic routing between clusters, making sure that your services are accessible to end user, even if one cluster or region experiences downtime or heavy load. It is amazing. Being honest, it is a good product. I'm very excited to explain you, or probably in a few minutes, the demo of my experience working with that. Implementation. Right now, all the most important, I think so, probably reviewing different products on the CNCF, the behavior of the approach is using controllers, operators, probably the factor right now in different products. If you see, for example, PG, I know, different products like MySQL operator, Postgre operator, Kafka, and so on, the mindset is operator. K8gb is operator, is implemented using this approach or this pattern. It leverages the Kubernetes operator pattern to manage and orchestrate the global load balancing capabilities. So we have probably different things important to mention there, like custom resource definition. You can implement this using CRDs, using the control loop, of course, in order to constantly checking the desired state versus the current state of the different cluster, different components into the cluster, integration with Kubernetes API, and of course, the idea using operator is automation and management. It is probably the most important thing about that. Why use this technology? Because we want to fault tolerance and high availability, low latency and traffic routing, and disaster recovery and resilience, of course. So different use cases, multi-region application, disaster recovery, and hybrid cloud deployments and all. So, okay, let me go and jump into the practice. Probably I spent 6 minutes. I promise 10 minutes, but 7 minutes is good. So, okay, this is the moment to explore this. If you can go to the page, K8gb.io, you can see this. I am finding, for example, the concepts, very important things. I explain a little bit the motivation, of course, what is the idea behind the goals, the different use cases. It is amazing because if you pay attention, you have different resources. Because the idea is not only coding and implementing this, the idea is to understand where and when, of course, you can implement this technology. So, for example, we have the first scenario, basic, single cluster. For example, you are here, you are accessing, and you have installed the operator, the K8gb in the cluster X. Imagine that we are talking about the region US, and here the region Europe, for example, for seeing something. So the user is requesting this to this operator, and of course, is working like a load balancer there, and this ingress controller is matching with the operator, and constantly all the requests from the user will be received from this cluster, and of course, return the information about the ingress. K8gb works very close with the ingress controller. For example, the GSLB resource has a specification like the ingress controller. So regularly, the most of the people researching on internet use Nginx, Ingress Nginx probably, but you can probably see another capabilities or capability that the feature has. So you see here, this cluster probably is not connected with the operator itself because we are using the single cluster. Of course, you can say, okay, Gerardo, but what do you want to use this for single cluster? Okay, sometimes it's needed, sometimes it's the specification, because probably you don't need to move to different regions. But probably the use case, or the most use case, is multiple or multi-cluster. It is basic. So here, you will have the same scenario that previous one, but we have the K8gb installed in both cluster and working with both ingresses. So we can use different strategies here. We can use fault tolerance. We can use round robin strategy in order to distribute the traffic in different clusters. So it's not complicated. I'm trying to see that. We have unhealthy multi-cluster. What happens if one cluster is down, or not the cluster, probably we're talking about the apps. If the apps that these ingresses is pointing go down for, I don't know, maintaining or something like that, no problem, because the operator is detecting if the ingress controller has or is pointing to healthy pods. If this operator found the pods are down, or something bad is happening, the DNS record is deleted from the operator. So it means that all the requests and the DNS resolver understand that this cluster is not healthy, is unhealthy, and redirect all the requests from another one cluster available. So it is intelligent thanks to the operator. Again, it is a good strategy from my perspective. Use operator is not right now is not nice to have. Is we need to do, because the operation right now, the scalability and resiliency is very important in this kind of products, because we can gain automation. So here we can see the different strategies, like I mentioned it, load balancing strategy that probably you know, round robin, way round robin, failover, GOP, with different configurations about that. Okay, what another one important architecture. I will read a little bit different components, internal component like controller, looping, CoreDNS. We can integrate this with external provider, for example, Azure, GCP, Route 53 from AWS, in order to manage the DNS. You can do it. You can have multi-cluster interoperability, works very good, different definition. And of course, you can do, or you can go to the repo. And in this repo, you will find amazing things. For example, different ways to deploy this in different providers, in local computer, local environment, all working with the Makefile. If you are probably familiar with the Makefile, you will understand that you can have different methods, and with this strategy, on Golang strategy, you can call different things and automate. But here in Makefile, you will find probably all the things that I will explain in a few minutes. So I clone this into my computer, and so I can share with you a demo. So go to the tutorials. Here you can see all the tutorials. It's interesting because if you see, it is probably the CRD, the basic simple CRD that we can use. So let me try to, probably be better or see better. We have the CRD. It's very simple, being honest. If you see, we have the kinds at GSLB, metadata, the specification, and here is the magic, because into the specification, we can point the resource reference, in this case, an ingress controller, or the ingress resource that you have installed. Of course, you can continue creating pods, deployment, services, ingress. Nice. Okay, you want to add this ingress to the load balancer, you can use the resource. Here, important thing, the strategy that you want to use, you can specify, remember, failover, GOIP, round robin, and the different options. So it is a simple CRD from ingress, and you can put, for example, the path, the host, all the different properties. It's very similar. I think it is the reason that I am saying that it's not complex to implement in the beginning, of course, because the syntax and the CRD is simple, is compact, is good from my perspective. We have, a lot of tutorials. You can see, for example, AWS examples using Route 53. You can use Azure Public DNS Provider. You can use metrics, traces, ingress annotation. You can integrate this with Rancher Fleet. So this, I think, so have different perspective, and this project constantly is growing. So let me, why not? I want to explore right now this example, local playground for testing and development. The first thing that I do regularly when I'm trying to create my POC or my research about one product is go to documentation and try to reproduce this locally, of course, in order that avoid cost. I prefer test this locally, destroy it, and enjoy it in my computer, and after that install this in one cloud provider. In my perspective, you choose like you want. So let me read a little bit. Okay, the first thing is to clone the project. Right now, I have the project cloned here, the K8gb. Nice. We have the makefile. In the makefile are all the different functions, implementations that the example used in order to create the tutorials. Prerequisites for these examples, or for this example, Go 1.22.3, Git, Docker. Okay, important, trying to have a reserve 8 gigabytes of memory in order to create the cluster. These examples are using K3D to run local K3S cluster. Minimum, the version required is 5.3.0. And of course, regularly the Golang CI lint, regularly in different distributions, especially Ubuntu already is installed. But if you are using other operating system, you can check this. In my case, I am using Ubuntu, and it's working relaxing very well. Okay, get started. Okay, the idea is to run or speed up a local environment using 2 K3S cluster to deploy this. I am curious, guys. So let me go to the make file and see what is happening behind the scenes. Okay, I am seeing that this method is creating a cluster with the name HDNS and is looping for cluster IDs, and probably will create another cluster, probably 2 clusters more. And after that, checking the version, if this test, so we'll release some images, and that's it. But it is already code allow us to accelerate the split up. For example, create local cluster. We can see that the only thing that we are doing is an echo and calling the K3D cluster create, and creating the cluster with the specific YAML. So that's it. It's understandable. So I am happy with that. So let me jump to this. Make deploy. We create in the cluster 3 Kubernetes cluster, the HDNS, and this make file or this command will create 2 more clusters. And every cluster has a tag in their application. It means, for example, every cluster, reviewing the code, has the pod info deployment there. The classic, the pod info deployment. So every pod in each cluster has a new tag with the name, region, or geographic thing, for example. So one cluster is, we are simulating Europe. In cluster 1 and cluster 2, we are emulating US, because the idea with this demo is trying to emulate or simulate a multi-cluster strategy. So if you see, this command is installing a lot of things. It's installing the Insto CRD, installing the Ingress controller, Nginx controller. Here, I will stop there, because here we are deploying the GSLB operator. So let me see what is probably the chart. Yeah, let me see. Okay, here, if you see, nice. It is Helm chart is installing for us. You can go, K8gb is another one, is an older Helm chart that you can use. You install it, the cluster you tag for this is Europe, and you can tag another one, US. You can specify different things, but probably most important right now is the image tag, the log level, the DNS servers. Invite you to go to the documentation of this Helm chart, of course, and review the different things. But for the moment, if you see, we are installing this, and it's simple if you want to install manually. What else? Deploy Ingress, Instio, CRDs, install InstioD, Ingress Gateway, deploy GSLB CRDs, Okay. Pod info. So it is the application that the load balancer will redirect the traffic using the pod info, the classic, our friend. The pod info is in everywhere example that I saw on internet. They're releasing the front end. It's simple. Okay. Ingress ready. Yeah, I think so. Let me see what is the status. Yeah, good. Looks like what finished. Being honest, my first impression, good. This strategy to have all set up for the beginners in this technology is simple because install it all the cluster with all the dependencies, a couple of clicks, and that's it. I think so for a newbie guy in this technology, it's good because you don't need to be an expert to set up this controller. You can understand better reviewing the code, but for the first time, the first touch, I think so, it's good. Okay, what else? Verify the installation. Okay. Say if local setup runs well, check if clusters are correctly installed. Okay. Recluster, nice. 1, 2, 3. Yeah, the DNS and Europe and US. Good. Cluster test GSLB1 is exposing external DNS on default port, while LB2 on this one. Nice. So what happened? Localhost. Okay, good. We have this command is interpreting the round rabbit cloud example.conf. If we review this right now, we can see we have right now 2 ingresses in our cluster. Round robin ingress, the host, round rabbit cloud example. Of course, it is that we are trying to dig in, and it's working. Our cluster is right now understanding this record, this DNS record. So it's good. The records, yeah, exactly. You can verify the correct IP address of all the nodes in both cluster. Yeah, amazing. Right now we are getting the name and IP of every cluster that we have. Every cluster has an agent and server. That's it. Good. Okay, both clusters have pod info installed on the top. Run following command and check if you get 2 JSON responses. Okay. Yeah, good. Oh, interesting. Because right now we are calling in from different ports, of course, 80 and 81. Probably every ingress in every cluster is pointing to different ports. And if you see the responses, it's practically the same, but the message is different. Europe, and US. So it means, yeah, all different pod info when we're deployed in every cluster, the makefile command tag this message into the pod. So it is the reason. So right now, our round robin is working. Round robin is working because we are trying to access one URL with one URL, and we are getting different resources or different responses. Let me see. Europe. Okay. Sounds good. On the port. Okay, it's good, interesting. Being honest, the documentation is good because right now it's checking that infrastructure is working, it's checking that the connectivity is working. Right now, install the pod info, a couple of clicks, and that's it. You have all the infrastructure created. Love it. So some sample demo. Both clusters have pod info installed on the top, where each cluster has been tagged to serve a different region, okay? In this demo, we will hit pod info by calling or hitting the roundrobin.cloud.example.conf, and depending on the region, pod info will return US or Europe in the current round robin implementation IP address. Okay, we need to call this, but we are curious. Please always read that you are trying to implement, because I don't know, it could be different things. But okay, it is simple. This method is calling, the test round robin, and so calling this method and pointing this. Probably it is a busy box pod, but let me go to there. This is the definition. Oh, yeah. If you see, it is a simple busy box. And this busy box, the only thing that is doing is executing this command. And of course, the URL is the first parameter that we are passing. And this, in this case, is this. Okay. It's not complex to understand. Let me call this. Make test round robin. Okay. We have this. Probably I am forgetting sometime. Make test round robin. We have Europe. Good. Let me see another thing we are ignoring. Expect the result. It should be pod info changing. Probably I need to call. Oh, nice. If you see in the in the first two times, the result was Europe. My term was US. The round robin is working well. It's routing the traffic using probably the weight of the different things. But probably the question that you have, but because my question right now is, what is the resource that is doing that? So, okay, let me trying to understand. kubectl get GSLB. Okay, we have right now 1, 2, 3, 4, 5, 6 resources. We are using probably it is the round robin ingress. Okay. Let me check this. kubectl describe GSLB. Oh, what is the namespace? The namespace is this. Okay, it is the description from robin. The status geotag US. Okay. Yeah, we're good. It is the CRD that is doing that. If we go to this, I think so. CRDs. Okay, this the CRD. Round robin ingress. Let me check with this. Round robin ingress, the name. Round robin ingress. Yeah, it is. So, okay, we have the specification, the ingress class name, nginx. And if you see, we are using the same rules that we use in the ingress resource. The host, we have right now 1, 2, 3 hosts in this ingress. So we are interested in the round robin, paths, backend, pod info. Okay. Good. What else? Host. Oh, here is the ingress. Sorry about that. My confusion. Yeah, here is the GSLB. And we are pointing the ingress. Okay, let me see. The ingress. Okay. It's interesting because if you see how the GSLB detects the ingresses, is using matching labels. If you see it right now, up, and this ingress has the same labels. It's pretty similar for how the services works. The services detect the pods using matching labels. So this ingress has this label, up, round robin test GSLB, and the resource GSLB is detecting the ingress or discover the ingress using the matching label. Okay, sounds good. Probably the operator helps to check the match label. A strategy, type round robin. Okay, good. We are splitting the brain threshold seconds and the DNL seconds. Okay. We can probably play with this and trying to figure out new options, new ways to do. So this makes sense. Use a round robin load balancing strategy when deciding which downstream cluster to route clients to. Threshold. Okay, this property is important. Split brain threshold second. Threshold after which external cluster is filtered out from the delegated zone with it doesn't looks alive. It's checking exactly if one ingress is down, is unhealthy. We have this threshold in order that to detect and constantly checking and go down or go up into the DNS. Right now, I am imagining that the GSLB resource is pointing to different ingresses and is creating the DNS record for every ingress. If one ingress is unhealthy, GSLB remove this entry because at the end, the operator needs to notify to the K8gb how many clusters are available. So it is probably a good strategy. DNS TLS seconds, TTL value for automatically created DNS records constantly, every probably 30 seconds is creating automatically the DNS record. Again, the operator is so good because if you add a new ingress and has this label, GSLB detects this DNS or this ingress and add to the DNS list. And probably you can imagine this like umbrella. And under the umbrella, we have all the different DNS, and every DNS could be ingress. Under the ingress, we have services. Under the services, we have the pods. So it's good because constantly, if one ingress is down, automatically the GSLB remove this from the list, and we constantly have updated DNS records from ingresses. I think so, thanks to the operator. Okay, I will continue checking. Oops, no, it's not. Takes round robin. Oh. I want to wait for US. Last one, and that's it. Okay, probably the round robin is working, but it's pointing to Europe. Okay. What else? Oh, the fifth US. Okay. Right now, is it the happy scenario when all works, all is good? Pura vida, like we say in Costa Rica, when all is good. But what happened if we move to failure scenarios? Probably we can see more about that. So reading this, oops, okay. Both cluster have pod info installed on the top, okay, where each cluster has been tagged to serve a different region. In this demo, we will hit pod info again, and depending on whether pod info is running inside the cluster, it returns only Europe or US. So see this, okay. It is another one, GSLB, failover ingress, the same, probably different failover strategy. Primary geotag. Okay, what does it mean? You want to learn more about that. K8gb, ingress annotation, arbitrary geotag. Okay, I want more info. Concepts, strategies, failover. I want pin it to a specified primary cluster. Okay, it means that this, for this GSLB, Europe is the primary cluster. Okay, I understand it. I understand it. Similar, no, it's primary cluster until workload on the cluster has no available pods. Yeah, amazing. I, being honest, I love this because if you understand right now what is happening, this operator constantly is checking if the pods are live or not. If the pods are healthy, all is good. If the pod has not, if this ingress controller has not available pods, K8gb remove this or ignore this and put this ingress like unhealthy. But when the pods come back to be healthy, automatically, thanks to the operator, the ingress come back to the list of the GSLB. So automation. Sorry, I repeat automation operator because I'm super fan of this. As not available pods upon which the next availability cluster ingress. Okay, IPs will be resolved. That I mentioned it. Yeah, upon which the next available clusters ingress node IPs will be resolved. When pods are again available on the primary cluster, the primary cluster will once again be the only eligible cluster for which cluster ingress nodes IP will resolve it. Okay. Okay, it means that this strategy create this like the primary cluster. They are specified in this case Europe, while Europe cluster or the pods in this cluster is working, all the traffic, the preference will be Europe, and the US is waiting for or probably being the backup, something like that. Okay, good. Okay. The failover. So probably this scenario is different because the idea is okay, create another one, GSLB, but the name is init failover. Oh, is sorry, it is failover ingress. Okay. Okay. Switch to this, and the idea is okay. In the first time, all is good. All the traffic is redirected to Europe, and if this cluster is down, the traffic needs to be redirected to the US. Okay, do it. I don't know, but sometimes that I am learning something or new things, I prefer to listen to music, I don't know, what is your strategy? So in the comments, you can put question, of course, and why not? I want to see if you are watching this, no live, probably in another moment, please put what is your favorite music and what kind of music do you listen when you are coding. Okay, init failover, if you see, we are switching to the context, the cluster, GSLB1, GSLB2. We're applying this. Okay, let me see to the code. Failover ingress. Failover ingress. Failover ingress. Yeah, it is. Okay. We are creating the ingress and the GSLB specifically, and the matching, of course. Search. Nice. What else? Ingress, okay. kubectl config, okay. To move to the other cluster, probably, and install it in both cluster. We are installing the same ingresses, of course, makes sense. But the difference will be that in one cluster, the pod info has Europe, like the I forget the name thing. So the message, and another one US is the different. Okay, make test failover. Probably I know it is another make file. Yeah, remember hit test app host. It probably it is the same strategy. BusyBox, yeah, BusyBot pod calling or getting or requesting one URL, and the one URL is failover cloud example. Okay. Okay. Boom. Waiting. Oh, then very good. Again, test failover. I can't continue calling this according to documentation. Always the result could be the same. Calling only the pod info where the message is Europe, because right now the active GSLB is the failover strategy. Three more. Okay. I want to check that it is working very well. The failure. Okay. Two. Okay. Same. Okay. Error. One more. I am right now QA. I am testing this. Okay. Probably I can continue in the next 2 hours calling this, and probably the result will be the same, because using the strategy, the failover strategy means that works very well. You will see only the Europod info is responsive. Okay, I check it. Okay, stop pod info on current cluster. Let me see what do this. Call test app set replicas 0. Amazing. I love it. Being honest, I love this. This makefile has, I am thinking different things that I can do with this makefile, because all these operators, you can put kubectl commands, pass parameters, and if you have a development team and they don't have experience in Kubernetes or kubectl, you can't automate this. A couple of commands. Okay, guys, I have this this guy. You can call this behind obscenes. You are creating commands or complex commands, and the people only call the method, and that's it. kubectl scale pod info. Okay, replicas. Okay, yeah. The first parameter, and the first parameter that I am calling or passing here is 0. Okay, good. Yeah, I understand what the idea. The idea is go down or scale down all the pod info from this cluster, and of course, the GSLB detects that this is unhealthy. The only choice they have is to redirect to another cluster. Okay, nice. Several times hit application again. US. Oh, good. If you see there right now is the US. Yes. Three more. Okay, US is good. First check. Okay, two. US. One more. Yeah, US. So good. Right now we have two behaviors: round robin strategy normally, and the failover. In this local demo works very well. It's good because I am going down the pods without any another configuration. The GSLB detects that the pods in the cluster, in the Europe cluster, are down, and no problem, no downtime. I redirect the traffic to the US. So good, so good. Okay, start pod info. Okay, start again. If we go to there, we can see that this called the same, but pass the parameter 2 in order to have two replicas for the pod info. Okay, yeah, exactly. If you see, nothing magic. The only thing that we are doing is scaling pods. All the magic is behind the scenes thanks to K8gb. Good. Make takes all. Okay, this is the moment to test this. Okay, K8gb, I trust in you. I trust you. Command. Oh, nice. If you see message, Europe, again, 3 times. We are an excellent QA, guys. 3 times. Failover. Okay, Europe. Okay, one more. Yeah, very good. So, excellent. It's working. So, optionally, you can switch GSLB back to round robin mode. Oh, let me try this. Okay, we want to come back to another strategy in order to see what happened. Okay, make init round robin. If you see, we are applying a new ingresses, and the round robin ingress on change, we are applying this in both clusters, and we can come back to this, make this round robin. Oh, good. Pura vida. It works very well. Right now, we are using round robin, and the only thing that we are changing is the GSLB, and that's it. It works. The operator is detecting the pods, is detecting the ingresses. When the ingress has pod healthy, unhealthy, redirect automatically. I think so. If you deploy this in a cloud provider for this demo, can work. Probably it's not complex. Of course, if you have advanced feature, could be, but for the moment, it's good. Okay. I am happy with that. I don't know, guys, if you are happy too, but remember, you can ask the questions, you can comment, and try to this. Being honest, my experience, very clear, understandable. I love these kind of things. For example, the make help, the make code. Congrats to these people, this team that is creating this, because it noticed that they are investing time to have a good experience, and this project sounds good, so interesting. Yes, George, it is about my presentation right now. I don't know what the people think, or you have probably a couple of times in order to continue to discuss this topic.
Yeah. Do you want me to pop in some questions here from the audience?
Okay.
Let's see. So we have this question about split brain, which was answered by Yuri. Okay, let me know when you read that, and then I'll tell you what Yuri says, and then maybe we can talk about it a little bit.
Yeah, how the DNS record will be updated. Yeah, exactly. It is thanks to the operator itself. Probably, according to the research that I did, the operator is constantly checking the ingresses from every cluster of the ingresses that the GSLB resource has attached, and detect if the pods are down or not. But it is automatically. The ingresses don't need to do anything. DevOps, nothing. All is in charge of the K8gb operator. So it is interesting and beautiful.
Yeah, and then do we have any questions? There's a few that were really complicated, and they're going to take that offline. Let's see that. Let's give the audience a chance if anyone has any last questions to come in. Thanks for dropping by, Yuri. Take the time. And then where can we find more information about K8gb? Do they have a meetup or anything coming up? Let me look. Let me just get their website up here. Oh, here's what you want here. I'm gonna toss this URL up here. You could just get this in the installation and configuration tutorials. If you scroll down on there, they have all of their presentations for the past KubeCons all lined up in there. So that's a good. I love it when projects do this. That's a great tip. From all sorts of different conferences and things like that. Online publications. They got links to books. So that is a handy tip there that I will do that. And then we will leave it with this.
Thanks so much. I am teaching words. Pura vida. Excellent, Yuri.
Yeah.
Nice.
All right. With that, we'll close it up. We'll see you all next week. I don't know offhand what we're doing, so you're going to have to keep following that CNCF LinkedIn channel. Subscribe to the YouTube channel. Smash that like and subscribe button. Help those metrics go up so we can keep it rolling. So thanks, everybody, and we'll see you all next week. You get the last word.
See you soon. Pura vida, guys. Enjoy it. Don't stop and follow the CNCF channels, because right now we're creating amazing content for you, and depends on you how you want to grow. So depends on you.
All right. Thanks.